Hello, welcome to 5.2 Day 1. Today we're going to learn about linear combinations and how we can convert a linear combination of sine plus cosine to just a single sine. Now in class we're doing an exploration 5.2a. It's a worksheet that goes along with the lesson, but as I go along the lesson I have slides that contain that information. First thing we need to figure out is what is a linear combination. Y equals 3 cosine theta plus 4 sine theta is called a linear combination of cosine and sine. That is y equals a constant, here the constant is 3 times cosine, plus another constant, 4 times a sine. In this exploration, we will learn how to express such a linear combination as a cosine with a phase displacement. So if we look at these two graphs, let's look and see which one is which. This should actually be cosine, 3 cosine theta. 3 cosine theta is going to start above at the top of its cycle, and it's going to go up and down 3 from this end. 4 sine of theta starts in the middle, goes up, down, and back. Now if I add these two together, I want you to just take a second and plot these two added together, which is 3 cosine. Now on your calculator it'll be an x plus 3 plus 4, sine x. Now you can sketch it on your worksheet if you'd like. Now what happens is you get an equation that doesn't look like either of them. It goes up a little higher, goes up to 5, and it goes down like this. So if we want to find this value, what we want to do is we can use a maximum function on our calculator. Now to find it, you press second trace, which is the calc function, go down to maximum, and you can figure it out from there. But this point is 5, and it's about 53. I can't write anything here. I'll try it again. 553. Now I'm messing everything up. It's 53 to the right, and 5 up. Alright. Now it's not 53 exactly, it's a decimal that goes along with that, but it's about there. So if I want to write this as 1 cosine, I could say this is y is equal to, my amplitude is 5, and I've shifted it to the right 53. So 5 cosine theta minus 53-ish. Now, so these two things equal the same thing. 3 cosine theta plus 4 sine of theta. This is equal to that, which is pretty amazing, because we can, if we have the cosine and the sine added together, we can just write it as 1 cosine. Alright, now we want to see where this 5 comes from. How do we go from a 3, a 4 to a 5? Well, that's in a 3, 4, 5 right triangle. And this 53 comes from that angle on the inside there. That equals the 53. Alright, now the period of that new function is the same, 360. And this is the point, 53, 5. The amplitude of the sinusoid is 5. And we found the phase displacement is 53.13. And so this was the equation, because we moved it to the right. Now we kind of already did that all at once, and we talked about how you can get to 5 using Pythagorean theorem, 3, 4, 5, and the 53.13 you get to find by finding that angle. Now, if you have the worksheet, do numbers 5 and 6. Now, let's look at number 7. Number 7, it says we want to convert negative 12 cosine theta plus 5 sine theta into 1 phase displacement, or 1 cosine with a phase displacement. So we're moving 12 to the left, 5 up. So this is a 5, 12, 13 triangle. So this is going to be 13. Now I want to find this angle here, which is a little tricky because I know the tangent of theta is 5 over negative 12. So if I want to solve this correctly, I'd say theta is the arctan of negative 5/12, which theta is the inverse tan of negative 5/12 plus 180n. Now, if I use my trusty calculator, the inverse tan of negative 5/12 is negative 22. Now, hopefully everybody knows negative 22 isn't over here. Negative 22 would be down here. Now, to get to that point, I would have to add 180 to it. So if I add 180 degrees, I'll find out that that angle that I'm looking at is 157.38. So to write my equation, it'll be 13 cosine of theta minus 157.38. Now these two equations are equal. We could graph this left-hand side and this right-hand side, and they would give us the same values. Alright, now this would walk us through it, but we already figured it out. Now here is the linear combination of cosine and sine. This is the equation for b cosine x plus c sine x is equal to a cosine of x minus t. Now I think this is more confusing than actually just learning how to deal with the problem. But this is just Pythagorean theorem squared, b squared plus c squared. D we get by finding the arctan of c over b. Alright, now do 8 and 9 if you have the worksheet. Here's number 8. Here we go 6 to the left, and then we go 11 down. So now we have to find our hypotenuse, which is 6 squared plus 11 squared equals c squared, 36 plus 121, which is 157. So we take the square root of 157. Now that's our new amplitude times the cosine of this angle. So if I take tangent of 11, or tangent of theta equals 11 over 6, theta would be the inverse tangent of 11 over 6 plus 180n. So first thing I want to do is find the inverse tangent of 11 over 6. And my answer is 61. 61 is up in this quadrant. So I have to add 180 to it. It's actually 61.39. If I add 180 to that, I get 241.39. So that's going to be my angle. So I'm going to say theta minus 241.39. Alright. Now in this problem, number 9, I go 9 in the cosine direction, negative 7 in the sine direction. Remember that cosine goes in the x direction, sine goes in the y direction. That's why the 9 goes there and the negative 7 goes there. So if I want to find my hypotenuse, 9 squared plus 7 squared equals c squared. 81 plus 49. That is 130. If I take the square root, that'll be that length. So that's my new amplitude. Oops. Theta. Now, tangent of theta equals negative 7/9. So theta is going to be the inverse tangent. I probably should have said the arctangent, but we can just write it out. Inverse tangent is negative 7/9 plus 180n. If if I take the inverse tangent of negative 7/9, negative 37.87. Now, is this negative 37.87? Hopefully you're shouting, yes, it is, negative 37.87. So I can use that angle here. Now, we usually say minus, but minus a negative will be a plus, 37.87. And so here's my answer. All right, hopefully that makes sense. Good luck with the homework.